welcome everybody. So today we'll be solving problem 1 of Project Euler in Python, JavaScript, Clojure, and Haskell. Now, I don't know much about the syntax of Haskell, but let's see if we can pick it up along the way. So without further ado, let's get it. Here we have an empty directory. Let's create a directory for the first question. Let's start with Python. Make a Jupyter notebook file and open up VS Code. Cool. Now, let's look at the question itself. We are supposed to find the sum of all the multiples of 3 or 5 below 1000. Let's copy and paste it here. And there are plenty of ways to do this, but first, let's start with writing a function that can simplify our lives, make our lives a little bit easier. So is divisible by, which checks whether or not a given number n is divisible by an arbitrary divisor. So it will return n modulo divisor equals to 0. Let's see if this works. It should. True? Yep. 6 is indeed divisible by 3. No surprises there. I guess the first method that comes to mind would be using a list comprehension, I for I in range of 1 to 1000. If, well, I think another way of writing this would be just to find a predicate for the entire question itself. So the predicate would be, it would return true if a number is divisible by 3 or 5. So let's write that is divisible by and 3, or is divisible by and 5. So if the predicate is met, the number shall remain, and let's just sum it up, 2333168. That is correct. We could also write this in a more imperative manner if we so choose to do so, which would look like this. If predicate I is passed, then we add to a sum variable, we increment it by I. Print that in the end, instantialize the sum variable first. Very cool. Now let's move on to JavaScript. We open a new JS file and open it up in VS Code. Let's try a line-by-line translation of this. So we're supposed to find the sum of all multiples of 3 or 5 below 1000. My favorite way of declaring a function in JavaScript would definitely be with the arrow constructor, the arrow shorthand or syntax, whatever. Const is divisible by is equals to and divisor. That's what I'm talking about. So this is pretty much a line-by-line translation of the same Python function. If n modulo divisor is equal to 0, then it returns true. Next level of abstraction, test whether or not the predicate is met for an arbitrary number. Returns is divisible by n3 or is divisible by n5. Let's check if this works for the number 15. Should return true. Run this via node py.js. True. Very cool. Next, we need an array. We need an array of integers. How we're going to do that is, let's do it via the spread operator. Array, let's say 10 for now, dot keys. Let's see if I got the syntax correct. I did indeed. We got all numbers here. So next thing we should do is we can actually run a filter through this. Filter through all the numbers that actually meet the predicate. Let's make this a variable and console.log this into our terminal. Very cool, makes sense. Next, we can add, let's use reduce. So reduce is one of the more functional ways where one can sum up a list in JavaScript. It looks a little bit like this. And if we console.log the answer, we should get what we want, 23, right? Because yeah, some of the numbers below 10, 23, that's correct. All we have to do now is to scale it up, console.log the answer again. Let's try this, 233168, correct. If we try to write this in a more imperative manner, just like what we did with Python, we could also do that. For let I equals to 0, while I is less than 1000, I plus plus, we could test for the predicate. So if predicate I is met, we can increment some sort of some variable, which we would declare right here. Let s be 0. At the very end, we will console.log s. So 233168, correct. Cool. Next, let's move on to Clojure. For that, we'll be using line again, line new app, p1 crj. Okay. Will be, I guess let's save it. Let's go to source core.clj. So this is what an empty, or rather new Clojure file looks like. Let's jack into a REPL. Read evaluation print loop, very cool. Clojure is actually one of my favorite languages. It's so fast to iterate upon. Let's remove main because we don't really need it here. And let's pretty much do the same thing. Let's define a function. It's div by, which takes in 2 arguments. Divisor returns true if n modulo divisor is equal to 0. We can test it out right here. 6-3. True. False. Cool. Next, we need some form of a sequence or list or integer. Thankfully, we have a built-in construct in Clojure, which is the range construct. We can see the results here. And the most straightforward way would probably be using filter and then applying a reduce operation. Let's have a second layer predicate, and or is div by, and 3. Yep, you can see that this is pretty much the exact same thing that I've been doing, that I was doing for Python and Clojure. So filter pred reduce plus. Very cool. There's also another way to write this, which would be using transducers. The speed gains won't be noticeable in this kind of problem because it's a very small scale problem, but it could come in handy when you're processing large amounts of data at once. So map, let's write an anonymous function. Map if the predicate is met for this anonymous variable, the variable will remain, otherwise it'll be 0. So that plus here, same answer. Very cool. It's also very convenient to time functions. It's not necessarily very because it just runs once, right? It's not very scientific, but it's a good heuristic. Yeah. So now let's move on to Haskell. Right, Haskell. Prior to this video, I actually downloaded everything I should need for the Haskell program. Let's see if it makes sense. I was using GHC, I believe. GHC Haskell. New project. Let's see how I instantialize that. User guide. First steps. GHC. I do have GHC. I suppose I could just write a Haskell file called p1.hs. Open that up in Visual Studio Code, which requires what, GHCUP. Really? Are you sure? It might be incorrect. Oh no, I was actually using stack earlier. So let's use stack. Haskell new project. How does one build with stack? Stack new, my project name. Let's go back to terminal, stack new p1 Haskell. Cool, so now we have this. Let's just do some cleaning, remove the p1.hs, cd into p1 Haskell, and open up that app in VS Code. Go to app. Right, so I know that the way to print something to the terminal would just be print. Let's go GHC, compile it, compile the compile main.hs. Oh, what? Right, of course. GHC main. Yeah, this is a rather convoluted workflow. Don't do this at home, kids. Right, so it does print ASDF, exactly what we wanted. So now let's check out the syntax for Haskell. Let's go to learn X in Y, my favorite resource for learning a new language, Haskell, or at least trying to somewhat get a bird's eye overview of a new language in terms of the syntax. Extremely efficient, extremely fast. Right, practical, purely functional programming language. Yes. The OR operator will come in handy. The equality operator will also come in handy. This will come in handy. This is a range. Right, so first, let's create a variable called numbers. Let's create a range. Print numbers. Let's see if this compiles. Surprisingly, it does. Wow, okay, cool. What we also need to do is to be able to sum a list or map. Oh, this is brilliant. List comprehension with a conditional. This is exactly what we need. So let's just modify this. X if, well, this is kind of like for I in the range, for X in the range of 1 to, let's say, 1,000. These are the predicates. So if, how do you do modulo? Modulo in Haskell. Backtick syntax. X modulo 3 equality, or X modulo 5. These will be the numbers. Let's just test it with 10. Let's call this answer instead. Let's try to compile this. Cool, that actually is correct, much to my surprise. Now we need to know how to sum a list in Haskell. Sum Haskell list. Very convenient. Compile this. No compilation errors. 33. Is that correct? It's not correct. Oh, okay. I get it now. It's inclusive. This is inclusive. (23). Correct. So now we just have to scale it up to 99, and we should get what we want. Hopefully. 233168. And yeah, okay. Well, that concludes problem 1 of Project Euler. Today we solved it with Python, JavaScript, Clojure, and Haskell. Hope that was somewhat interesting or mildly instructional. Do leave some feedback and stay tuned for more content. Thanks for watching.